Have you ever wondered how drones, these seemingly autonomous flying machines, are programmed to perform intricate tasks? The future of programming is being shaped by drone technology, revolutionizing numerous sectors. From monitoring crops in agriculture to keeping an eye out in surveillance, speeding up delivery services, and even providing breathtaking views in entertainment, drone programming is making significant impacts. It's a brave new world out there, and it's being coded one drone at a time. Without the right programming, a drone is just a piece of sophisticated flying hardware. To start with, you need to understand the basics of drone programming. So let's look at the key components involved in drone programming. Firstly, we have the drone's hardware. This is the physical aspect of the drone, the nuts and bolts, if you will. It includes everything from the motors that drive the propellers, to the sensors that detect obstacles, to the onboard computer that processes instructions. The hardware is the vessel that carries out the commands you'll be programming. Next up, the programming language. This is the tool you'll use to communicate with the drone's hardware. There are several languages out there you can use to program drones, but some of the most popular ones include Python, C++, and JavaScript. These languages allow you to write scripts that control the drone's flight, camera, and other functionalities. Think of the programming language as the translator between your ideas and the drone's actions. The third key component is the software or platform for coding. This is where you'll actually write and test your code. The platform can be as simple as a text editor or as complex as an integrated development environment, or IDE, that provides tools for debugging and testing. The software is your workspace, the place where your ideas take form and come to life. Now let's talk about how all these components fit together. When you write code in your chosen programming language, you're creating a set of instructions for the drone's hardware to follow. You write these instructions in the software, then send them to the drone. The drone's onboard computer interprets these instructions and sends signals to the various pieces of hardware to carry them out. If you've written your code correctly, the drone will perform the actions you've programmed. Every component in drone programming plays a crucial role. The hardware is the drone's body, carrying out the physical actions. The programming language is the mind, crafting the instructions, and the software is the heart, pumping life into your ideas. Remember, the hardware, the programming language, and the software all work together to bring your drone to life. Now that you know the basics, it's time to choose the right programming language for your drone. When it comes to programming drones, there are several languages you can choose from, but for the sake of brevity, let's focus on the two giants, Python and C++. Python, known for its simplicity and readability, is a great choice for beginners. It's a high-level language that abstracts away many of the complexities of programming, allowing you to focus on what you want your drone to do, rather than how to do it. However, this simplicity does come at a cost. Python tends to be slower than lower-level languages, which could be a drawback if you're working with a drone that needs to make rapid adjustments in response to its environment. On the other hand, we have C++, a lower-level language that gives you more control over your drone's hardware. This added control can result in more efficient and responsive applications, making C++ a good choice for more complex projects. However, with great power comes great responsibility. C++ is less forgiving than Python and requires a deeper understanding of programming concepts, which can be daunting for beginners. So, how do you choose between Python and C++? Well, it depends on your drone's intended use. If you're just getting started and your drone's tasks are relatively simple, Python may be the way to go. However, if you're planning on developing a sophisticated drone application, or if speed and efficiency are your top priorities, C++ might be your best bet. Remember, there's no one-size-fits-all solution when it comes to programming languages. Each language has its strengths and weaknesses, and the best choice depends on your specific needs and circumstances. It might take some trial and error, but with time and experience, you'll find the language that best fits your drone programming project. Choosing the right programming language is crucial for developing efficient and responsive drone applications. Ready to get your hands dirty with drone programming? Let's dive right into it. The first step in our drone programming adventure is setting up our development environment. We'll be using Python, a powerful and versatile language that's great for beginners and pros alike. To get started, you'll need to install Python on your computer, which you can download from the official Python website. Once you've installed Python, You'll also want to install an Integrated Development Environment, or IDE. This is where you'll be writing and testing your code. There are many options to choose from, but we recommend PyCharm or Visual Studio Code. Now that we have our development environment ready, it's time to start writing some code. We're going to program a simple operation, making the drone take off, hover for a few seconds, and then land. To do this, we first need to import the drone library. This library provides us with a set of commands that we can use to control our drone. Our code might look something like this. Here we're calling 3 functions: take off, hover, and land. The hover function takes an argument, which is the number of seconds we want the drone to hover. Once we've written our code, it's time to test it. This is where things can get a little tricky. Drones are complex machines, and there are many things that can go wrong. You might encounter issues like the drone not taking off, not hovering, or not landing. These issues could be caused by a variety of factors, such as a problem with the drone itself, a problem with the code, or even a problem with the environment. This is where debugging comes in. Debugging is the process of finding and fixing issues in your code. It can be a challenging process, but it's also one of the most rewarding aspects of programming. When debugging, it's important to be systematic. Start by identifying the problem, then try to isolate the cause of the problem. Once you've identified the cause, you can start working on a solution. There are many tools and techniques you can use to debug your code. One of the most basic and useful tools is print statements. By inserting print statements into your code, you can see what's happening at each step of the program. This can help you identify where things are going wrong. Now, debugging is twice as hard as writing the code in the first place, as Brian Kernighan, a pioneer of computer programming, once said. Therefore, if you write the code as cleverly as possible, you are, by definition, not smart enough to debug it. So remember, keep your code simple and clear, and there you have it. We've walked through the process of setting up a development environment, writing some simple drone code, testing it, and debugging any issues. It might seem daunting at first, but don't worry. With practice and patience, you'll soon be able to program complex drone operations. Once you're comfortable with the basics, it's time to explore some advanced drone programming concepts. Let's dive into the fascinating realm of autonomous flight. Autonomous flight is all about enabling your drone to fly independently without requiring constant human input. This is achieved through the use of GPS waypoints, which guide the drone on its flight path. The drone is programmed to move from one waypoint to another, making decisions based on its programming and sensor data. Next up is object detection. This is where your drone distinguishes between different objects in its environment. It's akin to teaching your drone to see, and it's an essential component of autonomous flight. Object detection is often achieved through machine learning algorithms, where the drone is taught to recognize different objects based on a vast array of training data. And then there's collision avoidance. This concept is all about programming your drone to detect potential obstacles and avoid them. It's a crucial safety measure that ensures your drone doesn't crash into trees, buildings, or other drones. This is usually implemented using sensors like LiDAR or ultrasonic rangefinders that can detect objects in the drone's path and adjust its course accordingly. These advanced concepts are just scratching the surface of what's possible in drone programming. By mastering them, you can enable your drone to carry out complex tasks, from delivering packages autonomously to performing precision farming operations. Advanced drone programming opens up a world of possibilities, from autonomous deliveries to precision farming. We've covered a lot of ground in this short video. We embarked on a journey into the future of programming and dived deep into the fascinating world of drone programming. We've covered everything from the basics, understanding the machinery, to the nitty-gritty of choosing the right language for your drone. We even got our hands dirty with some hands-on drone programming, didn't we? And let's not forget those advanced concepts we delved into, giving you a sneak peek into the vast expanse of knowledge that awaits you in this field. Remember, this is just the beginning. The world of drone programming is ever evolving, filled with endless possibilities. It's a vast ocean of knowledge waiting for you to dive in. So don't stop here. Continue exploring, continue learning, practice, experiment, innovate, and who knows, you might be the one to revolutionize the field of drone programming. Keep exploring, keep learning, and who knows, you might be the one to revolutionize the field of drone programming.